For the second operation on functions, we have subtraction of functions. We let f and g be the functions with domains d sub f and d sub g respectively. The difference of the two functions f and g, denoted by f minus g, is the function defined by f minus g of x, which is equal to f of x minus g of x. The domain of f minus g of x is the intersection of the domains of f and g. So let's have our first example under subtraction of functions. We have here our two functions f and g. F of x is equal to x plus 5 and g of x is equal to negative 4x minus 20. So we will look into the difference of the two functions f and g. Okay, so we start with the definition of the operation f minus g of x, which is equal to f of x minus g of x. Then we substitute our functions x plus 5 minus negative 4x minus 20. We distribute the operation to negative 4x minus 20. So we have here x plus 5 plus 4x plus 20. We combine like terms. X plus 4x is 5x, and 5 plus 20 is positive 25. So the difference of f and g functions is 5x plus 25. For the domain of f minus g, that will be all set of real numbers. For the second example, we have here g of x, which is equal to negative 4x minus 20, and m of x, which is equal to x squared minus 4x plus 4. We get the difference of g and m functions. Okay, so start off with the definition. G minus m of x, which is equal to g of x minus m of x. We substitute the functions. Negative 4x minus 20 minus x squared minus 4x plus 4. We distribute the operation to x squared minus 4x plus 4. We have 4x minus 20 minus x squared plus 4x minus 4. Then we combine like terms. We shall have then negative x squared. Okay, you always start with the coefficient or the variable with the highest term. The highest exponent, I should say. Negative x squared. We have here negative 4x plus 4x, that's 0. Negative 20 minus 4 is negative 24. So the difference of g and m is negative x squared minus 24. For the domain of g minus m, that is still all set of real numbers. Let's have the third example. We have here f of x, which is equal to x plus 5, and n of x, which is equal to square root of 2x minus 1. We solve for f minus n of x. Okay, so one function given is a linear function, and the other function is a square root function. Okay, so let's start. F minus n of x is equal to f of x minus n of x. We substitute the functions x plus 5 minus square root of 2x minus 1. Okay, just like the addition of functions on this third example, we cannot combine the terms. So we will just copy it. X plus 5 minus square root of 2x minus 1. Okay, and that will be the difference of n of f and n functions. For the domain of f minus n. Okay. Take note that the domain of the f function is the set of all real numbers. And for n of x, the domain there is all real numbers greater than or equal to 1/2. Okay. So that the intersection of the two domains will be all real numbers greater than or equal to 1/2. Okay. To make the new function defined together with, of course, the n of x function. Let's have our fourth example using f and p functions. So f of x is equal to x plus 5 and p of x is equal to 3x plus 1 over x squared minus 25. We solve for the difference of the two given functions. So f minus p of x, which is equal to f of x minus p of x. We substitute the functions x plus 5 minus 3x plus 1 over x squared minus 25. Okay, so we get the LCD, which is x squared minus 25. Okay, so LCD divided by 1, which is the denominator of x plus 5, is x squared minus 25 times the numerator x plus 5 minus the LCD divided by the denominator x squared minus 25 is 1 times the numerator 3x plus 1 over the LCD x squared minus 25. Okay, so we get the product of the two binomials, x squared times x is x cubed, negative 25 times x is negative 25x, x squared times 5 is positive x squared, and negative 25 times 5 is negative 125 minus 3x minus 1 over x squared minus 25. Okay, then we combine like terms. We copy x cubed plus 5x squared minus negative 25x minus 3x is negative 28x, and negative 125 minus 1, it's negative 126 over x squared minus 25. So that is the difference of f and p functions. For the domain of f and p, take note that the domain of f is all set of real numbers, and the domain of p is, for the p function, we will exclude 5 and negative 5. Okay, so all real numbers less than negative 5, union 5, negative 5, 5, union all real numbers greater than 5. Okay, so for the intersection of the two domains then, d sub f minus p, since we are excluding negative 5 and positive 5 based on the new function we also consider the given function, which is p of x. Okay, so the domain of f minus p is all set of real numbers less than -5, union of -5, 5, union of 5, or all real numbers greater than 5. Let's have our fifth example under subtraction of functions using j and m functions. So j of x is equal to 2x plus 4 over x minus 2, and m of x is equal to x squared minus 4x plus 4. So we solve the difference of the two functions. Okay, so let's have here j minus m of x, which is equal to j of x minus m of x. We substitute the functions to x plus 4 over x minus 2 minus x squared minus 4x plus 4. Okay, so we get the LCD, which is x minus 2. Okay, so LCD x minus 2 divided by x minus 2 is 1 times the numerator, which is 2x plus 4. Then the LCD divided by 1, which is the denominator of x squared minus 4x plus 4, is x minus 2 times the numerator x squared minus 4x plus 4 over x minus 2. Okay, so we have here 2x plus 4 minus, we multiply these terms, x times x squared is x cubed, x times negative 4x is negative 4x squared, x times 4 is positive 4x. Then negative 2 times x squared is negative 2x squared. Negative 2 times negative 4x is positive 8x. And negative 2 times 4 is negative 8. Okay, over the LCD x minus 2. Okay, then we simplify or distribute the operation. We have here 2x plus 4 minus x cubed. We have here negative 4x squared minus 2x squared is negative 6x squared. So plus 6x squared. Then 4x plus 8x is 12x times negative. That's negative 12x. And negative 8 times negative is positive 8 over x minus 2. We combine like terms. We have here negative x cubed plus 6x squared plus 2x minus 12x is negative 10x plus 8 over x minus 2. And that is the difference of j and m function. For the domain of the domain of the j function is, we exclude the value that will make the denominator 0. So that is all set of real numbers less than 2, union of all real numbers greater than 2. Well, for d sub m, or the domain of the m function, that is a quadratic function. So the domain is the set of all real numbers. And we need to get the intersection of the two domains. Then the domain of J minus M is all real numbers less than 2 and a union of all real numbers greater than 2. So for the last example, we have J of x, which is equal to 2x plus 4 over x minus 2, and P of x, which is equal to 3x plus 1 over x squared minus 25. So we get the difference of J and P. So J minus P of x is equal to J of x minus P of x, which is equal to, we substitute the given functions, 2x plus 4 over x minus 2 minus 3x plus 1 over x squared minus 25. Okay, then we get the LCD. The LCD is x minus 2 and x squared minus 25. Okay, so LCD divided by x minus 2 is x squared minus 25 times the numerator 2x plus 4 minus the LCD x minus 2 and x squared minus 25 divided by the denominator x squared minus 25, so that is x minus 2 times the numerator 3x plus 1 over the LCD x minus 2 and x squared minus 25. Okay, so we multiply the binomials. X squared times 2x is 2x cubed. Negative 25 times 2x is negative 50x. X squared times 4 is 4x squared. And negative 25 times 4 is negative 100. Okay, so minus the product of the remaining binomials. We have here x times 3x is 3x squared. Negative 2 times 3x is negative 6x. X times 1 is x. And negative 2 times 1 is negative 2. Okay, over the LCD, x minus 2 and x squared minus 25. Okay, so we combine like terms and distribute the operation. We have here 2x cubed plus 4x squared minus 50x minus 100 minus 3x squared. Negative 6x plus x is negative 5x times negative is plus 5x. Then plus 2 over x minus 2 and x squared minus 25. Okay, so let's combine like terms. We have here 2x cubed, 4x squared minus 3x squared is x squared. Negative 50x plus 5x is negative 45x. And negative 100 plus 2, it's positive 98 or plus 98. Over, we multiply the two binomials on the denominator as well. We shall have then x cubed minus 2x squared minus 25x plus 50. Okay, so that is the difference of J and P of x. For the domain, as you can see, we have here two rational functions. So we get the domain of J, and the domain of J is all real numbers less than 2, union of all real numbers greater than 2. Okay, while for the domain of the P function, okay, on the denominator, hindi pwede si negative 5 and si positive 5. Because if we will substitute those two values mentioned, x is equal to negative 5 or x is equal to positive 5, then it will make the denominator 0. So the function then, or the domain then is all real numbers less than negative 5, union of negative 5 and 5, union of all real numbers greater than 5. Okay, so we get the intersection of the two domains. The domain of j minus p then is, if we try to use the number line, we have here negative 5, excluding negative 5. We have here 2, excluding 2. And we have here 5, excluding 5. Okay, so with the help of that one, we can determine the intersection of the domains. All real numbers less than negative 5, union of negative 5 and 2, union of 2, 5, union of all real numbers greater than 5. Okay, so that is the domain of j minus p. In other words, we cannot use the numbers or the values negative 5, 2, and 5 to the new function and to the given functions, which are j and p, so that the functions will be defined.